Today's lesson deals with solving one-step inequalities. Your learning target says, I can translate a worded problem into an inequality and determine a solution set. It should also say, I can graph my solution set. So the key to solving and writing inequalities is to understand the vocabulary that matches each symbol. So I want you to make this chart in your interactive math notebook. So pause me while you do that and then come back when you're ready to fill it in. All right, so our symbols. This first symbol you see, this is actually a less than symbol. And you might see some cue words. I can't write everything, of course, but you might see something like smaller. You might see fewer, under, below. Those types of words will clue you in that you have a less than symbol. Next symbol, this is greater than. Some clue words might be that something is bigger or more, over and above. Those kinds of words will clue you in that you have a greater than symbol. These last two symbols that you see, these are combination symbols. So this next one means that you have something that is less than or equal to. Some clue words might be at most, no more than, and the last symbol is greater than or equal to. And you might see the words at least, no less than. One last thing for background information. You're going to be graphing your solution set, and so it's going to be important that you know whether you need an open circle or a closed circle when you go to dot your answer. And so you're going to leave your circle open if the number is not part of the solution set. So for example, if your symbols were less than or greater than, you would have this open circle to show that everything is right up to that number, but not including that number. On the other hand, you're going to use a closed dot if the number is part of your solution set. So for example, if you have symbols that are less than and equal to or greater than and equal to. And that shows that that is part of that set and everything beyond. For the most part, solving an inequality is no different than solving an equation, except for one minor difference that we're going to get to later in the lesson. And so here we have an addition problem. We know from our earlier work that we're going to use an inverse operation. We have to isolate this variable by subtracting 9 from both sides. 9 minus 9 goes away. I have x on the left. I have 9 on the right. And my symbol was less than. The newest twist is to graph this. And so we've graphed a little bit, and I said I usually put the target in the center with one more and one less. I need to pay attention though, because I have to know if I want an open circle or a closed circle. And I have a less than. That means my number, all the numbers less than 9 are my solution set, not including 9, so I'm not going to close in the dot because it doesn't equal 9. It's everything less than, but not including. So my dot, my circle, needs to be nice and open. And of course, I want to be pretty obvious which way on the number line I am coloring in. Pause me while you work this one out and graph it and when you're ready for checking, come back. I worked through this problem and I added 11 to both sides. That left y on the left side and 4 on the right, and my symbol is greater than or equal to. Because 4 is part of my solution set, I'm going to close my dot. Y, my answer, is everything greater than and including 4, so I'm going to be obvious about which side of my number line is getting colored in. Same deal. I want you to pause me while you work this out and graph it. Come back when you're ready for checking. I solved this problem using division. I divided both sides by 1 and 1/3. That left 2 and 1/4 on one side and b on the other. My symbol is less than or equal to. Now, if it bothers you that the variable is at the end, you can also make it at the beginning. I just want you to pay attention. Do you see how this sign is open like an alligator mouth towards the B? If you're going to flip things around so your variable comes first, the alligator mouth still needs to be open towards the B. These are equivalent expressions, and so that might make you a little more comfortable when you go to graph it. So B, my answer set, is everything greater than and including 2 and 1/4. So I'm going to have a closed dot to show that 2 and 1/4 is part of my solution set. And I'm going to color in everything greater than that. Be pretty obnoxiously evident where you're grading or graphing, sorry. All right, same deal. This is our last one of these type. I want you to go ahead and solve it and graph it and come back when you're ready to check against my work. Here is my solution. I multiplied both sides by 10 and I ended up with b on the left, 7 and 1/7 on the right, and I brought down my sign. Now my solution set does not include 7 and 1/7. It is everything greater than, but not including 7 and 1/7. So I can't color in my dot, but I am going to shade obnoxiously evidently the side that needs to be shaded. At the beginning of the video, I told you that solving inequalities was pretty much exactly like solving equations, except for one difference. And here it is, one huge, important difference. If to solve your equation, you must multiply or divide both sides by the same negative number, you must switch your sign. So let's talk about why that works. I think we'd all agree that -2 is less than +2. But what happens if I were to multiply both sides by the same negative number? I'm not altering anything as long as I do the same thing to the left and the right. -2 times -1 is +2, and 2 times -1 is -2. If I were to leave my sign, that would no longer be a true statement. Because I multiplied or divided by the same negative number, I have to flip my sign. Now that's hard for kids to remember, so be sure you're thinking if you multiply or divide by a negative, flip your sign. Solve and graph this equation, and when you're ready for checking, come back. In order to solve this equation, I have to divide both sides by -6. That leaves m on the right and 7 on the left. But notice, this is a -6. Because of that, I have to switch my sign. So that means 7 is greater than or equal to all of my solution set. Remember I told you earlier, you could flip this around if you want to. The alligator mouth is eating the 7, so you have to keep it like that. But if it makes you happier to have your variable first, you could flip that around if you wanted to. So 7 is part of my solution set. Originally, it said that 7 was greater than or equal to everything. So whether you said it the first way or you flipped it and said m is less than or equal to 7, this is your graph. Solve and graph this one. Pause me while you work. Come back when you're ready for checking. To solve this one, I had to multiply both sides by -4. That left y on the left and -12 on the right. Notice this is a negative. Because I had to solve using a multiply by negative number, I have to flip my sign. Y is greater than, but not equal to, so I have an open dot, -12. So all of this is leading up to us being able to see a story problem, find the inequality, and solve it. So it says Juanita is going bowling and has $25 to spend. If each game costs $4, find the maximum number of games she can bowl. I only want you to write the equation and solve it. You don't have to graph this one. So pause me while you work it out, and when you're ready to see what I did, come back. So we know Juanita has a maximum of $25 and that each game costs her $4. So $4 for every game can be at most no more than $25 if you look back at our chart. So to solve that, I'm going to divide both sides by 4. And the game she bowls is going to come out to be a decimal, I believe. But in reality, you can't really bowl part of a game. They won't allow you to pay for part. And so the game she plays has to be less than, or could be exactly, 6 games. All right, this is your last problem. I would like you to write an inequality. This should say inequality. And solve it. When you're ready to see how I did it, you'll come back for checking. All right, so it's going to take Alfonso 3/4 an hour for every lawn, and he wants that to be at least 15 hours. So if I look at my chart, at least is greater than or equal to 15 hours. To solve this, I would divide both sides by 3/4. Oops, 3/4. That leaves the lawns on one side and 20 on the other. So if he wants to work at least 15 hours, he is going to mow more than or equal to 20 lawns.